Hey everyone, welcome back to my channel. I'm thrilled to have you here again. If you're new, make sure to subscribe so you don't miss out on any of my tutorials. In our last video, we explored the basics of getting started with the Agent Development Kit, or ADK for short. We walked through setting up a simple agent, and if you haven't seen that yet, I highly recommend checking it out. It'll give you a solid foundation for what we're building on today. Trust me, it'll make things a lot easier to follow. So today we're diving into something really exciting, building a team of multiple agents working together. I'm going to take you through a step-by-step tutorial where we'll explore how to create a group of agents that collaborate on tasks. We'll start by looking at some helpful documentation for a tool called LiteLLM, which makes it super easy to connect with different AI models. I'll show you how to find the right model names, check pricing, set up billing, and create API keys for these models. By the end, you'll have everything you need to get started with calling multiple agents into action. And as a bonus toward the end of this video, I'm going to share a personal project I've been working on. It's a workflow designed to refine and improve the metadata for my YouTube videos. Think titles, descriptions, and tags. I've built a team of AI agents using models like Gemini, GPT Claude, Deepseek, and even xAI's Grok. These agents work together to critique, refine, vote on, and aggregate suggestions for better metadata. We'll use different components like basic agents, sequential and parallel agents, and even custom ones. I'll also show how to incorporate features like session memory and specific tools into the process. It's a practical example that I think you'll find really cool and useful. One of the best parts is that we'll be using the ADK's web interface to visualize the entire workflow. You'll see how these agents are created, how they communicate with each other, execute tasks, and call tools back and forth. It's a fantastic way to understand how everything comes together and generates results. Honestly, it's pretty amazing to watch in action. Alright, let's jump right in. First, let's do a quick recap. Last time, we built a simple weather agent using a couple of tools to fetch data. Today, we're taking it up a notch by creating a full weatherbot team. This team will use different AI models like Gemini, GPT, and Claude, and will set up specialized sub-agents for specific tasks like greeting users or saying goodbye. We'll also enable intelligent delegation so the right agent handles the right task, add memory to the agents using session state for more personalized interactions, and even implement safety guardrails with callbacks to keep things secure. In this advanced tutorial, we're going to cover how to define and use tools to give agents specific abilities like fetching data or performing tasks. We'll configure agents to work with leading AI models using the LiteLLM package, which is an awesome library for connecting to various models. I'll show you the documentation for that later. We'll also talk about agent delegation and collaboration, where sub-agents are specialized for certain roles and tasks are automatically routed to the right agent in the team. Another important topic we'll cover is using session state for memory. This allows agents to remember information across conversations, making interactions feel more natural and contextual. And of course, we'll look at safety guardrails using callbacks, which let you block requests or enforce rules before they reach the AI models. While our goal isn't just to build a functional weather bot system, this example will help us grasp these core ideas. Then I'll pivot to my personal project, which is a lot more practical and fun to explore, especially since it's something I'm using for my own YouTube content. Before we dive deeper, make sure you've completed the ADK Quickstart tutorials. If not, no worries. You can check out the official documentation or watch my previous video for a refresher, I'll link it in the description below so you can catch up quickly. Alright, let's move forward. First things first, we need to install the necessary packages. Make sure you've got the Google ADK package and LiteLLM installed, as they're crucial for this tutorial. Next, we'll import the libraries we need, including components for creating agents, managing session memory with an in-memory session service, and running the interactions with a runner tool. We'll also bring in some types for crafting messages and content. And of course, don't forget to configure your API keys for the AI models you'll be using. For example, you'll need keys for Google's Gemini, OpenAI's GPT-4, and Anthropic's Claude 3 Sonnet. Just plug in the specific model versions you want to work with, and you're good to go. Let's start by building a basic agent, something like a weather assistant. We've covered tool definitions in the past, so I won't go over that again here. But essentially, you'll give this agent a name, specify which AI model it should use, and write a clear description of its purpose. Then, you'll craft detailed instructions for how it should behave and what tools it can access, like a function for fetching weather data. It's a best practice to be very specific in these instructions so the agent knows exactly what to do. Next, we need to set up the runner and session service, which are super important for managing conversations. The session service handles the conversation history for different users and sessions, while the runner orchestrates the interaction flow. It takes user input, routes it to the right agent, manages calls to the AI models and tools, updates the session memory, and tracks the progress of each interaction. To set this up, start with an in-memory session service, define an app name like Weather App, assign a user ID and session ID, and wrap it all into a session. Then, create the runner by linking it to the weather assistant agent we defined earlier, along with the app, name, and session service. That's the backbone of how everything will run. Now, let's talk about how to interact with our agent. We'll send messages to it and receive responses using an asynchronous helper function. This function takes a user query, calls the runner to process it within the user's session context, and then loops through the events generated by the runner. These events could be things like a tool being called, a result coming back, or the final response from the agent. The asynchronous setup is key because it keeps things efficient. While waiting for a response from one AI model, the system can handle other tasks without getting stuck. Once the final response is ready, we can extract and display it. Pretty neat, right? To run a full conversation, we'll wrap these asynchronous calls into a main function and execute it. For example, you can send a series of user queries like asking about the weather in a specific city, and the system will process each one, returning the responses in turn. It's a straightforward way to test how the agent handles a back and forth interaction. This is the standard approach for defining a single agent and having a conversation with it, and it's critical to understand concepts like session IDs and the runner before moving on to more complex setups. Now, let's get into something even more exciting, working with multiple AI models using LiteLLM. Why use different models? Well, each one has unique strengths. Some are great at coding, others excel at reasoning or writing, and they vary in cost, capabilities like context, window size, and availability. With ADK and LiteLLM, you've got the flexibility to tap into over 100 different models, which is incredibly powerful. To set this up, you simply import LiteLLM, specify the model name when building an agent, and make sure it matches what's in the LiteLLM documentation. Follow their naming conventions, and you'll be able to seamlessly switch between models like Gemini or Claude for different agents. Alright, let's move on to building a full agent team with delegation. Imagine you've got a main agent handling weather requests, but you also want specialized agents for greetings and farewells. First, define tools for saying hello and goodbye. Then, create sub-agents. One for greetings using a model like Gemini 2.0 Flash with instructions to provide friendly hellos, and another for farewells with instructions to handle goodbyes. Make sure the instructions clearly state which tools to use for each task. Next, define a root agent, let's call it the weather agent team, also using Gemini 2.0 Flash. This root agent will handle weather requests directly but delegate greetings and farewells to the sub-agents. In the instructions, explain that it's the main agent for weather data using a weather fetching tool, but it has specialized helpers for saying hi and bye. This automatic delegation is a key concept and makes the system really smart. To interact with this team, we set up a conversation function just like before, but now it's for the entire agent group. Create a session service and runner for the team, linking it to the root agent. Then send a series of queries like, hello there, what's the weather in New York? Thanks, bye. What you'll see is the greeting agent handling the hello with its specific tool, the root agent managing the weather request with its weather tool, and the farewell agent stepping in for the bye with its goodbye tool. It's amazing to watch how tasks are automatically delegated to the right agent based on the context. Next, let's talk about adding memory and personalization using session state. Think of session state as a simple storage system like a dictionary in Python where you can save key value pairs. Agents and tools can read from and write to this storage, allowing them to remember details across multiple conversational turns within a session. Tools can access this through a special context object provided by ADK, reading preferences or saving results as they execute. Agents can also be set up to automatically save their responses under specific keys in this storage, making it easy to recall past interactions. To set this up, initialize a session with an initial state, like setting the preferred temperature unit to Celsius. Later, you can retrieve or update this state as needed. Let's build on that by creating a weather tool that's aware of the session state. Define a function to fetch weather data for a city and include a context argument that lets it access the session state. Inside the function, read the user's preferred temperature unit, say Celsius, from the state. Then, if the raw data is in Fahrenheit, convert it to Celsius before responding. This makes the tool context aware, tailoring the response to the user's preference. It's a small but powerful way to demonstrate how session state can personalize interactions. Now, let's test this state-aware setup. Define your agent team again, including the greeting and farewell sub-agents, and set the root agent to use this new state-aware weather tool. Create a runner for this setup and run a conversation where you first ask about the weather in London, expecting a response in Celsius based on the initial state. Then manually update the session state to change the preference to Fahrenheit and ask about the weather in New York. This time, the response should reflect the updated preference. Finally, send a simple greeting to see the greeting agent in action. You can even check the final session state afterward to confirm the preference was updated. This shows how memory works across turns and how you can adapt responses dynamically. Lastly, let's touch on safety guardrails using callbacks. This feature lets you add logic to block or validate user queries before they reach the AI models. You can set up rules to filter out certain requests or enforce safety policies using a callback context and request data. I'm not using this in my current projects, so I won't dive deep into it today, but it's a powerful tool to explore if you need to add safety measures to your system. Feel free to check the documentation for more details on implementing callbacks before model or tool calls. Before we dive into the main content, let's take a quick look at the LiteLLM documentation. I want to make sure we all understand how to find and set up API keys, figure out the right model names to use. So when you check out the LiteLLM documentation, you'll see a list of supported model providers. For instance, if you're planning to use OpenAI models, you'll need to set up your API key with a specific name, the OpenAI API key. It's pretty straightforward, but important to get right. When it comes to naming the models, you'll typically use a format that starts with a prefix. While we're on the topic of models, I want to point out that you can always look up the pricing for each one. This is really useful to do before you commit to using a specific model. The cost is generally calculated per million tokens. Next, let's talk about the OpenAI API console. Before you can make any requests, you'll need to add some credit to your account. It's a simple step, but you can't skip it if you want to start using the API. Once you've got the billing sorted out, head over to the API key section in the console. From there, you can easily create a new secret key. Now, I'm also going to incorporate some models from XAI, specifically Grok. For this, you'll need to set up the XAI API key and follow their model naming format. It's a similar process to what we did with OpenAI, just with a different provider. You can check the pricing for XAI models, and it's also based on a per million tokens rate. All the details are available in their documentation, so you can find exactly what you need. One interesting thing about the XAI console is that they offer free credits if you're okay with their team having access to test your API requests. They also provide a generous monthly free credit of about 150, which is awesome to take advantage of. Of course, you can always purchase additional credits if you need more. Once that's done, you can head to the API key section and create your key just like we did before. Moving on, I'm also going to use models from Anthropic. You'll define the Anthropic API key for this and stick to their naming convention. You can check the pricing for Anthropic models, and it's calculated per million tokens as well. Take a look at their options and choose the model that works best for your project. There's a lot to explore here. In the Anthropic API console, the process is pretty similar. Head to the billing or payment section to set up your credits. Once that's ready, you can create your API key right there. I have to say their layout is pretty interesting and user-friendly. Alright, let's move on to the Gemini API from Google. You'll define the Gemini API key and follow their model naming format. You can find all the available Gemini models on their dedicated page. Now let's talk about pricing for Gemini. At the moment, they offer free tiers for most users, which is fantastic. For example, with the Flash model, you might get something like 10 requests per minute and up to 500 requests per day. For the Pro experimental version, it's a bit more limited. Think around 5 requests per minute and 25 per day. These numbers might vary slightly depending on the exact model or tier, but it's a cool opportunity to test things out without any cost. To get started, just head over to Google AI Studio, create your API key there, and you're good to go. Next up, I'm going to include the Deepseek models. You'll set up the Deepseek API key and follow their naming convention. When it comes to Deepseek, you can check out their pricing and model options. They've got two main ones, a chat model, which points to something like Deepseek v3, and a reasoner model for more analytical tasks. All the details are laid out clearly in their platform. The Deepseek platform, you'll top up your account with some funds to get started. Once that's done, you can create your API key just like with the other providers. So that's the lineup of models I'm planning to use for this project. You might be wondering why I chose these specific ones. Well, I'm basing my selection on rankings from sources like the LMC's chatbot arena leaderboard. My goal is to use some of the top performing models to enhance content and improve metadata. It's all about getting the best results. As you can see, among the models we're using are Gemini, GPT-4, Grok from XAI, the Gemini Flash Preview, and Deepseek v3. These are all strong contenders based on current rankings, and I'm excited to put them to work. Now, I also want to include Claude from Anthropic, even though it might not be at the very top of the rankings right now. Alright, everyone, I'm super excited because we've finally arrived at my personal project. Let's dive right in and explore what we're going to build together today. In this project, we're creating a multi-agent system using the Google Agent Development Kit, or ADK for short, to enhance my YouTube video metadata. That means we'll be improving things like the title, description, and tags to make my videos more discoverable and engaging. As I mentioned earlier, this system involves several agents working together. First up, we have a greeter agent that kicks things off by fetching the initial data. Once the greeter gets us started, we move into the criticism phase. Here, multiple agents run simultaneously to analyze the existing metadata. They'll look at the current title, description, and tags, and provide feedback based on additional context we provide. Next, we enter the refinement phase, where these same language model agents take all the feedback from the criticism stage and work together again in parallel to improve the metadata. After that, we have a voting phase. Each agent votes on the refined options, but here's the catch: they won't vote for their own suggestions to keep things fair and unbiased. Finally, I've created a custom aggregation agent that tallies up all the votes and ranks the proposed refinements to give us the best final result. This custom aggregation agent is built using various components from the ADK, like the language model agent, base agent, sequential agent, and parallel agent. If you're curious about how these workflow agents work, I recommend checking out the ADK documentation for a deeper dive later on. Let's talk about how I set this up. First, I imported all the necessary packages from the ADK, including the tools for creating language model agents and managing workflows like sequential and parallel processing. Next, I define some constants like the app name, user ID, and session ID. I also specified the language models I'm using for this project. These include models like Gemini Flash, Gemini Pro, GPT-4, Claude Sonnet, Deepseek Chat, and Grok. I've even set aside a specific model for the greeter agent. I also set up something called state keys. These are essentially labels that help store and retrieve information during the session, allowing the agents to communicate and pass data between each other. For example, they can save responses or read data needed for the next steps. Keeping these consistent is super important for the workflow to run smoothly. To guide each agent, I've prepared specific instructions loaded from separate text files. I've organized them into folders so the greeter agent, for instance, gets its instructions from a file called greeter instruction. Similarly, there are tailored instructions for the critic, refiner, and voter agents. Let's talk about the starting point for our metadata. I've defined the initial state for the title, description, tags, and even some supporting documents. This is actually based on one of my earlier videos, the Quickstart guide, where we built a weather information agent using a couple of tools with ADK. The supporting documents include details about my channel and some video content analysis, possibly done by Gemini 2.5 Pro, to give the agents extra context to work with. Moving on, I set up instances of different language models using a library called LiteLLM, which integrates nicely with ADK. The code checks for API keys for providers like Gemini, OpenAI, Anthropic, Deepseek, and XAI. If a key is missing, it falls back to using Gemini Flash for that provider's agents, ensuring the workflow doesn't break. A quick reminder, make sure you've defined your API keys for services like OpenAI and Anthropic in your environment variables. Now, let's talk about the tools I've built for these agents. The first one is a tool for fetching initial metadata. It grabs the starting data we defined and saves it into the session state using our state keys, making it accessible to all the agents that follow. The second tool is designed for the refiner agents. It pulls the initial metadata along with all the feedback from the critic agents, looking for specific state keys related to criticism and bundles everything together. Lastly, there's a tool for the voter agents. This one gathers all the refined metadata and criticisms but excludes the refinement created by the voter's own corresponding refiner to prevent self-voting. It's all about keeping the process fair. Alright, let's get into defining the agents themselves. First, we have the greeter agent, which uses a specific model and set of instructions. It's equipped with the tool for fetching initial metadata and saves its output to a state key called greeting a message. Next, we create critic agents for each available language model provider like Gemini, GPT, and Claude. Each one has a unique name, such as Gemini Critic or GPT Critic, uses its respective model, follows shared critic instructions, and saves its feedback to a specific state key like Gemini criticism. They all use the initial metadata tool to start their analysis, and their job is to critique the title, description, and tags in a structured format. Similarly, I've set up refiner agents for each model provider with names like Gemini Refiner or GPT Refiner. Their instructions guide them to revise the metadata based on the original data and the collected criticisms using a tool specifically for fetching both. Then come the voter agents, created in the same way for each provider. They use a tool to access all refinements and criticisms, accept their own, and rank the options based on specific voting instructions. Now let's talk about something special, a custom vote aggregator agent I built by extending the base agent class from ADK. If you're curious about creating custom agents, the documentation has great examples. In this agent, I've defined unique behavior in an asynchronous function that processes the session state. It accesses all the voting results from the voter agents, parses their rankings, and calculates scores, giving higher points to top ranked refinements. Finally, it outputs the aggregated ranking as a result and updates the session state with the final ranking. It's a neat way to wrap up the voting process. To keep everything organized, I've used ADK's workflow agents. These aren't language model agents themselves, but are designed to control how other agents execute. For example, a sequential agent runs its sub-agents one after another, a loop agent repeats until a condition is met, and a parallel agent runs multiple agents at once to save time. I've structured the criticism phase as a parallel agent with all the critic agents running together, the refinement phase with all refiner agents, and the voting phase with all voter agents. The greeter and aggregator, however, run solo at the start and end. I've tied everything together in a big sequential workflow agent called the multi-model refinement workflow, which executes each phase in order: greeter, criticism, refinement, voting, and finally aggregation. With the structure in place, I set up a simple in-memory session service, initialized the session with the starting metadata, and created a runner to execute this root workflow agent. I also wrote a function to start the process asynchronously. Once the workflow finishes, It retrieves the final results from the session state, displays the ranking, and even saves the entire state to a file called final session state. The main execution block checks for API keys, warns if any are missing but allows fallbacks, and then runs the whole thing asynchronously. So that's the logic behind this entire project. Now let's run it and see what happens. I'm starting the process, and first the greeter agent responds with a friendly hello there. It's great to have you here. I'll fetch the initial metadata and outlines the steps we're about to go through. You can see the sequential workflow I've set up with phases like criticism, refinement, voting, and aggregation, each containing agents for models like Gemini, GPT, Claude, Deepseek, and XAI. It's all running smoothly, so let's wait for the results to come in. All right, we've got the final results. It looks like the refinement from XAI scored the highest with 16 points, ranked first by 4 voters. Coming in second is Claude's refinement with 13 points, followed by Gemini, Deepseek, and GPT. Let's take a closer look at how this unfolded. The greeter started by fetching the initial metadata, title, description, tags, and supporting content, and explained the multi-phase process. Then, in the criticism phase, each agent provided feedback. For example, the GPT critic noted that while the title had good keywords, it was too long and could be trimmed. XAI suggested adding a clickable hook like a step by step or in minutes to attract viewers. Claude pointed out the title lacked a strong hook and felt a bit dated, while Gemini recommended explicitly mentioning Python. In the refinement phase, the agents took this feedback and revised the metadata. GPT, for instance, came up with a shorter title like Google Agent Quickstart. Build a Gemini AI agent in Python, explaining it improved readability and SEO. XAI, Claude, and others offered their own polished versions. Then, during the voting phase, each agent ranked the refinements, excluding their own. Interestingly, most voters, including GPT, Gemini, and Deepseek, picked XAI's refinement as the best, citing how it addressed the majority of criticisms with a concise title, strong keywords, and an engaging description. So that's pretty much it for today's project. I've had a blast building this, not just to learn how to create multi-agent systems with ADK, but also to apply it to something practical like improving my YouTube channel's metadata. I'm going to use XAI's refinement for my video since it came out on top. I'll update the title, description, and tags based on this winning suggestion. Thanks so much for sticking with me through this super long tutorial. I hope you enjoyed it and had as much fun as I did. If you have any questions or ideas, please drop a comment below. I'd love to hear from you. Until next time, take care, and I'll see you in the next video.